Welcome back to my today's section on network analysis. Myself, Dr. Sayanti Chatterjee, Associate Professor of Electrical and Electronics Engineering Department of IARE. Today we are discussing some problem on AC circuit analysis. So already I have discussed about the course objectives, and today again we are going to discuss the transient analysis of AC and DC circuits. And what is the course outcome? The course outcome is the discuss the steady state response and resonance of electrical circuits to AC supply. So we are going to our first question, number 1. A 60 Hz voltage of 115 volt RMS. So we are telling about the RMS voltage is impressed on a 100 ohm resistance. Write the time equations for the voltage and the resulting current. Let the 0 point of the voltage at the T equals to 0. So this is a very simple question. So we have to write the basic equations of the RLC circuit. Here it is given that the RMS value is 115 volt. So what is the maximum voltage? The maximum voltage formula is root 2V. So the value is root 2 into 115 volt. So the value is coming as the 163 volt. Next value is we are calculating the what is the equation of an AC? AC equation is Vm sin omega t, or we can write sin. What is the meaning of omega? Omega is equal to 2 pi f. So 2 pi 3.14 into what is f? F is the frequency, and frequency is given here 60 Hz. So we are getting the 377 radian per second. So we got the maximum value, we got the omega. So what is the value of Vm? Vm is 163 sin 377. So Vt is equal to, and here it is told it is started from the 0 point. So if we are drawing one curve, it has been started from the 0 point. It has been started from the 0 point. What is IT? IT value is given as the IT is equal to voltage by resistance. So it is 1.63 sin 377 t. So this is our first question. So we have discussed. We are going for our second question. A 50 microfarad capacitor is connected across a 230 volt 50 Hz supply. Calculate the reactance offered by the capacitor and maximum current. See RMS value of the current drawn by the capacitor. Similarly, now we are thinking about a capacitive circuit. So for a capacitive circuit, the supply voltage is given 230 volt. So the value is the 50 Hz. What is omega then? Omega value will be 230 2 pi f. 2 into 3.14 into 50 means 314 second. It is 230 volt means obviously this is an RMS value. So what is the maximum value? What is Vmax? Vmax would be 233 by root 2 volt. So the Vt value we are getting 232 into root 3 by sin 140 volt. Calculate the reactance offered by the capacitor. Calculate the reactance offered by the capacitor. So what is the value of Xc? Xc we know 1 by omega c. Omega value we have calculated 314, and the capacitor value is given in the problem is 50 microfarad, means 50 into 10 to the power minus 6. So the Xc value we are getting here is 63.6 ohm. What is the value we are getting here? We are getting here 63.6 ohm. So what is the current across this? The current is V minus Xc is equal to 3.62 ohm. And again, as we have taken here V 230 volt, what is the maximum current? Maximum current is root 2 into I. So it is coming 5.11 ampere. So what is the current value? Current value is, we know from the civil rule, in the voltage across the capacitor is always 90 degree leading. So the voltage, if it is the current is always 90 degree leading the voltage, so by angle of 90 degree. So 5.11314T, this is the normal current, plus pi by 2. Pi by 2 means the current across the capacitor. So we got the second question also. Next, we are discussing the another question. In a series circuit containing pure resistance and pure inductance. So this is a pure resistance and pure inductance, and the current is flowing in the circuit. The current value is expressed as the IT is equal to 5314T plus 2 pi t. So IT value flowing this is the 314T plus 2 pi t, and Vt is equal to 15 by sine 314T plus 5 pi by 6. What is the impedance of the circuit? So impedance is always V by I. What is impedance? Impedance is equal to V by I. But remember one thing, that is the current and voltage both are in the some phase angle is there. So first we have to change the phase angle. How to calculate the phase angle? What is the meaning of 2 pi by 3? It is 1 pi. Pi means 180 degree. Pi is equal to 180 degree. So 2 pi by 3 means it is coming 120 degree. Similarly, the 5 pi by 6 is equal to 150 degree. So what is the angle between them? The angle between them is 30 degree. Now what is the value of Z? Z value we can calculate. Here we are got the maximum value. So Z value is equal to V max by I max. So the value of this is coming to the 3 ohm. Then next question is, what is the value of the resistance? So it is a simple RL circuit. If we draw the RL circuit, this is the voltage, this is the IR current is in series, and according to the civil rule, voltage is leads and current is lagging in inductor. Voltage is leading and current is lagging in the inductor. So voltage is leading. So what is the voltage? This is our I into XL. This is I into R, and this is our I by I into Z. So what is the resistance? Resistance, if it is the phi, so cos phi is equal to R by Z. We know the cos phi is 30 degree because the angle between the voltage and current is 30 degree. We got the previously. So cos 30 degree is equal to 0.866. So R is equal to 2.6 ohm. Next we have to calculate the XL. XL means this angle. So again sin phi is equal to XL by Z. So similarly we are getting the XL value is 1.5, but we have to calculate the value of the inductance. What is the value of the inductance? XL is equal to, we know, 2 pi F into L. So 2 into 3.14 into 50 Hertz into L is equal to our value 1.5. So L value is coming as 4.78 millihenry. Next question, we are coming to our question number 4. A pure resistance of 50 ohm is in series with the pure capacitance of 100 microfarads. The series combination is connected with a 100 volt 50 hertz supply. Find the impedance, current, phase angle, voltage across the resistor and voltage across the capacitor. So what is happening here? One pure resistance of 50 ohms is connected with a pure capacitance of 100 microfarads in series. It is in the series connection, and we are giving 100 volt supply here. We are giving 100 volt 50 hertz supply here. So first you find the impedance. So what is the formula of impedance? We know Z is, what is the value? Z is equal to root of R square plus XC square. And what is XC? XC is equal to 1 by 2 pi fc. So what is xc? 1 by 2 pi fc. Actually it is 100 into 10 to the power minus 6. xc is equal to, c value is the 100 microfarad. So xc is equal to 1 by 2 into pi into f into 100 into 10 to the power 6. So we are getting the value 32 ohm. The resistance value in the problem is given 50 ohm. So what is Z? Z is equal to, already we have discussed in our previous slide, root of r square plus x square. So what is the value? The value is coming as 59.4 volt. Next is the current. What is the current? V by Z. What is the current? Current is V by Z. So V value we know, Z value we know, it is the value 1.6984. But here one thing we have to remember, here we are getting the only the magnitude of the current, but we have to calculate the phase angle of the current. So how to calculate the phase angle? If we draw the circuit, this is our voltage, and as this is a series circuit, we are taking the base as the current, and then we are drawing the voltage drop is IR. The voltage drop across the current is IR, and this is our the current is the IC here. So what is the I? So this is the, and what is the voltage across the capacitor? This is the voltage across the capacitor by 90 degree. This is the voltage across the resistor. So what is the angle if we draw the phasor diagram? This is our voltage V, and this is the angle phi. So what is phi? Actually phi is equal to V by VR. What is phi? Phi is equal to cos inverse V, VR by V. What is VR? We can write cos inverse IR by IZ. So it is cos inverse R. What is the R value in this problem? The value of R is 50 ohm and Z value is 59.4. So cos inverse 50 by 59.4, that is cos inverse 0.842 is equal to 32.36 degrees. 36 degree. What is the voltage across the resistor? The voltage across the resistor is
చూడండి ఫస్ట్ టైం వచ్చారు అక్కడ మన మెయిన్ క్యాంపస్ లో ఫుల్ ఉంటది. అది ఇదేమో లైక్ దీని చూసి అది చేశారు. అది అప్డేటెడ్.
So what is the voltage? Voltage is equal to I into R is equal to 50 into 1.684 is equal to 84.2 volt. What is VC? VC is equal to I into XC is equal to current value we know. So 1.684 we got the current value before, 1.684 into XC. XC value also we have calculated here 32 ohm. We have calculated the XC value here. So the voltage across the capacitor is 53.9 volt. Again, if we want to calculate by this, phi is equal to cos inverse VR 84.2 by total V. We can also get the same answer. The voltage is 100 volt. So again we are getting the value cos inverse 0.842, and you will get the angle. So any process you can use to calculate the angle. Next question is question number 5. A resistance of 20 ohm, an inductance of 0.2 Henry and capacitance of 100 microfarad are connected in series. Now we are coming for one more thing, that is the inductance. So again, what is Z? Z is equal to root of R square plus XL minus XC square. So which one is XL? XL value is equal to 2 pi FL. So what is the 2 pi FL? 2 into 3.14 into 50 into 0.2 Henry. So it is 100 into 200, and 3.14 into 200 means 700. We are getting the value 314 into 0.2. So similarly, we can get the xc value. Xc is equal to 1 by 2 pi fc is equal to 314. 2 pi f is equal to 214 into 100 microfarad, 100 into 10 to the power minus 6. So if we put the value xl, we are getting 0.63.6, and xc value we got sim value 32 ohm. So what is x? X is equal to, what is xl minus xc? Here you can see xl is greater than xc. So xl minus xc is equal to 31 ohm. So it is an inductive circuit. Next, what is Z? Z is equal to square root of R square plus XL minus XC square. So R square means already it is given in the problem 20 square plus 31 square. So Z is equal to 37 ohm. What is the current? Current is equal to, again current is equal to V by Z. V is 220 volt, 220 by Z, 6 ampere. But remember, the V is in the RMS value only, and here also I value we are getting the RMS value only. What is the voltage across the resistor? The voltage across the resistor is equal to I into R, that is 120 volt. Voltage across the capacitor is equal to, voltage across the inductor is equal to 6 into 63 means 278 volt, and VC is equal to 6 into 32 means 192 volt. Next, question number 6. A 240 volt 50 Hz AC supply is applied to a coil of 0.08 Henry inductance and 4 ohm resistance connected in series with a capacitor of 8 microfarad. Again, we have to calculate the impedance, circuit current, phase angle, power factor, power consumed, and Q factor for the resonant circuit. So first is the impedance. Impedance is the same one. So what is the XL value we are getting here? XL. What is XL? XL is equal to 2 pi f into L. So 2 into 3.14 into 50 into 0.08. So the value of XL is coming as 25.12 ohm. What is the value of XC? XC is equal to 1 by 2 pi FC is equal to 1 by 314 into, it is 8 microfarad, so 8 into 10 to the power minus 6. So the value of XC is coming as the 398 ohm. So what is the, it is XL is less than XC, or rather we can tell XC is greater than XL. So this circuit is an capacitive circuit. So this is a capacitive circuit. What is Z? Z is equal to root of R square plus XL minus XC square. We can write XC minus XL square, as this is a square, it doesn't depends on the sign of the problem. So Z is equal to 373 ohm. What is current? Current is equal to V by Z. So Z value we got, voltage value is given in the problem 220 volt. So the value is coming as 0.643. Next, we can calculate the phase angle also. Actually, the phase angle formula is cos phi tan inverse R by Z. R by Z. As the R value is very small, what is the R value? R value is given here 4 ohm, and Z value is given as very big 370 ohm. So the value is almost coming 89 degree. Actually, cos pi is equal to R by Z. So R value is 4 ohm by 373. So phi value is almost 89.91. So we can write it 90 degree. And why minus? As this is a capacitive circuit, the current is the voltage is lagging the current, and so that is an we can tell, if we draw the circuit, this is the I, this is the VR, This is the VC and this is our V. As the voltage is lagging the current, so we can write the phase angle is minus 90 degree. What is the power? Power is equal to I squared into Z. I value we know, Z value we know, we can calculate, or we can calculate the power by power is equal to V I cos phi. We can use any of the form. What is the quality factor? Quality factor is equal to omega. Actually, quality factor is equal to 1 by omega into R into C. So, if we calculate the omega means 2 pi F R into C, we are getting the value is, Q value is 25. So, this is the problem, this is the answer of this problem. Next question is the resistance of 20 ohm, inductance of 0.2 Henry and a capacitance of 100 microfarad are connected in series. Determine the impedance. Already we have discussed this problem, so I am not repeating. Next important question is question number 9. A series resonance network consisting of a resistor of 30 ohm and a capacitor of 2 microfarad, inductance of 20 millihenry, connected across a sinusoidal supply voltage which has a constant output of 9 volts. Calculate the resonant frequency, the current and the resonance, current at resonance, the voltage across the inductor and the capacitor at resonance frequency, quality factor and bandwidth. So we will calculate one by one. Calculate the resonant frequency. How to calculate the resonant frequency? We know F is equal to 1 by 2 pi root of LC. So 1 by 2 pi root of L value is 20 millihenry and C value is given 2 microfarad. So the value is coming as 796 hertz. What is the current at the resonance? Next question is the current at the resonance. So 9 at the resonance condition, the circuit becomes resistive. So we can write V by R is equal to 9 by 30 is equal to 0.3 ampere or 300 milliampere. Next, we have to calculate the inductive, the voltage across the inductor and capacitor. We know at the resonance condition, the voltage across the inductor and the voltage across the capacitor both are same. So, how to calculate? First, inductive reactance. Inductive reactance XL is equal to 2 pi FL. 2 pi, A value is 796. Remember, in the resonance condition, frequency must be the resonant frequency. This is a very common mistake for the students, that we are taking the frequency 50 Hz, 60 Hz like this. But this is a special case. We are just considering the resonant frequency. So XL is equal to 2 pi FL is equal to 2 pi 796 into 0.02 is equal to 100 ohm. So what is the voltage across the inductor and capacitor? Voltage across the inductance is equal to I into XL. So I value we got 300 milliampere and we are getting the 100 ohm. So it is 30 volt. We can also calculate this like XC is equal to 1 by 2 pi FC, 1 by 2 into 3.14 into 796 into C value which is given in the problem, 2 microfarad, 2 into 10 to the power minus 6, and VC is equal to I into XC. That is also correct process, but in this process you can calculate any of the value. Next is the quality factor. What is quality factor? Quality factor Q is equal to omega L by R. So omega L value we got already, XL value is 100 ohm we got, R value is 30. So what is Q? Q is 3.33. You can also calculate the Q value is equal to 1 by XR into XC or 1 by omega RC. But again in this point you have to remember 2 pi into 796 again R into C. What is bandwidth? Bandwidth is equal to resonance frequency by the quality factor. So 796 by 3.33. So that this value is the 2.238 hertz. Moving to our question number 10. A coil having an inductance of 50 millihenry and a resistance of 10 ohm is connected in series with a 25 microfarad capacitor across a 200 volt AC supply. Calculate the resonant frequency. Just remember one thing again, 50 millihenry and the 10 ohm resistance. 50 millihenry and 10 ohm resistance is connected with a 25 microfarad capacitor across a 200 volt AC supply. So this is our circuit. Now first we have to check actually correct value of the F naught. What is the formula of F naught? F naught formula is 1 by 2 pi root of 1 by LC minus R square by L square. For this type of circuit, the resonant frequency value is 1 by 2 pi square root of 1 by LC minus R square by L square. But if the value of 1 by LC is much greater than R, we can take R value is negligible. So here we are getting the same case that the 1 by LC is much greater than the R value. So we are just much greater than means minimum 100 times greater than the R value. So we can just eliminate the R. So we are just taking the R as a negligible. We are taking the R as a negligible value. So what is the value we are getting? F naught is equal to 1 by root of LC. So the value is coming 142.3 hertz. What is I naught? I naught is the current flowing through the resonance condition, and we know at the resonance condition the dominating is the only the resistance. So 200 by 10 is equal to 10 ampere. What is the quality factor? Quality factor we can calculate in the different value. Omega naught L by R. Again, what is omega naught? Omega naught is equal to 2 pi F naught. So 2 into pi into 142.3. Remember, it should not be the value which is 50 hertz or 60 hertz. It is the resonance frequency. Or we can calculate omega naught R by C, or we can write 1 by R root of L by C, and any form you can use, the value will come 4.47. Remember that the Q naught is the only one thing which is the dimensionless or unitless. Other values have some unit. Next, question number 11. For a parallel resonant circuit shown below, the value of the frequency is dash, and also calculate the Q factor and bandwidth. So here the values are given. What is the value of F naught? Already we discussed. 1 by 2 pi root of 1 by LC minus R square by L square. Again, the value of 1 by LC is equal to 1 by 162 into picofarad. Pico means 10 to the power minus 12, and L value is 100 microhenry. So, and the value of R is 7 ohm only. So R is very small. R is very small than this. So we can write F naught is equal to 1 by 2 pi root of LC. We can simply write the resonant frequency is F naught is equal to 1 by 2 pi root of LC, and if we put the value, we are getting the value as 1.25 megahertz. The value is coming 1.25 megahertz. What is the value of the quality factor? We know the quality factor is equal to XL by R, and XL value is equal to 2 pi F naught L by 2 pi F naught L by R. F naught is equal to 1.25 megahertz. Remember the value of F naught. We can also use the formula 1 by R root of L by C. This formula is also, we can calculate using this formula also, and for all the values we are getting the value of XL is equal to 100 in 0.5. What is the value of bandwidth? Bandwidth value we know F naught by Q. F naught value is 1.25. Its value is 100, so the value is coming as F naught by R and F naught by Q, so the value is coming 6.2. Actually the value is coming, this is one wrong, the value is coming 12.5 kilohertz, but one thing we are taking the half, every side the frequency is equal to 6.25 kilohertz. Question number 12. Consider the circuit shown in the figure. Calculate the resonant frequency of the tank. Tank means this portion is the tank only. So again we can see this is 10 ohm. Similarly we will again check 1 by LC. 1 by LC means nano. 1 nano 10 to the power 9 into L is 1 milli 10 to the power minus 3. So the value is 10 to the power 12, which is much greater than the 10. So we can write that this is, though it is an RLC circuit, the value of frequency we have discussed before, but what is the value we are taking here? What is the value we are getting? The frequency? Frequency is 1 by 2 by root of LC. So 1 by 2 into 3.14 into square root of 10 to the power 12 means 10 to the power 6 by 2 into 3.14. What is the Q factor of the coil? The Q factor of the coil is, we can calculate as the omega naught L by R. Omega naught L or omega naught L means 2 pi. Here remember that the frequency is 2 pi resonant frequency L by R. So the same problem we are discussing here also. Next, find a coil of inductance 5 millihenry and resistance is 10 ohm is again connected in parallel with 250 nanofarad capacitor across a 50 volt subvariable 50 volt variable frequency supply. Determine the resonant frequency, dynamic resistance, current at resonance, and the Q factor. So first one is the F naught. So F naught we know the formula 1 by 2 pi. As if we draw this 5 Henry 5 millihenry inductance is connected to a resistance, and they are connected with parallel with the 250. So this is 10 ohm. This is 5 millihenry. This is 250 nanofarad connected with a 50 volt supply. So what is happening here? Again we have to calculate 1 by root LC, and we can see 10 to the power 9, 10 to the power minus 3 must be much bigger than the resistance. So what is happening here? We are just using the simple formula 1 by 2 pi root of LC, and we are getting the value 4490 Hertz. Next question is calculate the dynamic resistance. Actually the correct term is the dynamic impedance, but as L and C value is not important, that's why we are sometimes call it the dynamic resistance. So dynamic resistance value is equal to L by RC. L by RC or CR. So L value is given here 50, C value is given, R value is given, so it is coming 2000 ohm. This is known as the dynamic resistance. Next is the current at the resonance. What is the current at the resonance? The current at the resonance is equal to V. Actual value is the V by RD. V by RD, because in this case we are with the not normal resistance, we have to take the dynamic resistance, as resistance is connected with the resistance is connected with the inductor. So what is the V? V value is given as the 50 by dynamic resistance is 2000 ohm. So it is coming the value is and what is the q what is the value of the q factor? Q factor value we know xl by r. Xl means 2 pi f naught l by r. So if we put the value, we can get the value is coming as 14.1. The value is coming as the 14. We are getting the value 14.1. So today we have discussed about the different textbooks of A. Chakraborty, A. Sudhakar, Valkenberg and some websites, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.